Hello world, and welcome back to another video. Now this is going to be a very interesting video to me. It's going to combine two things. First of all, we're going to take a look at replicating a linked list implementation with Kotlin, but we're going to do it with a twist. We are actually going to approach this test-driven, which means that we're going to be focusing first on writing the tests, and then we are going to be implementing according to the test. We're going to follow a regular and typical test-driven cycle, which means we're going to go from red to green to refactor, which means we're going to first see the test failing, maybe we're going to have some compiler errors, we're going to fix them, make the test pass, and then we're going to clean up the things that we already have in place. So I have created an empty Android Studio project because I'm just more familiar with that way of writing Kotlin, which is probably an overkill. We're going to create a main function, and then we're going to start creating our classes and run them, and we're going to see the results in the console. So let's begin. Okay, so we are in Android Studio. First of all, I have an empty package here, so we're going to create our first class, which is going to be linked list implementation. Let's do it like that. So this is going to be a linked list class, and we are actually going to have that as a generic, which means that we're going to make it so that we can add any type to it. Of course, for simplicity, I'm thinking of using integers for now, but for better completion of that task, it would be better to already have that signature in place with the generic. So let's do it like that. And of course, immediately what I'm going to do is I'm going to go to generate, and this will help me generate a test for this class. Generate a test. There we go. I'm using JUnit 4 because I'm more familiar with it, but feel free to, you can always use JUnit 5, of course. I'm going to add the setup and before method to be included, and putting it in the unit test folder. Beautiful. So now we have our basic setup here. So what I'm actually going to do is I'm going to split that into two, which means I'm going to have the implementation on the left and the test on the right, which is actually going to help me have a better visualization side by side as things are going. So now we have already our first warnings from Android Studio, but we don't really care about that. We're going to go about it as usual. Now in the test-driven development cycle, it means that we first start by writing a test. Now we don't have a failing test, we don't have any implementation, so what we basically need to do is we're going to have to create a failing test. So let's focus on the right here, on the test class. First of all, we need to have a var which is going to be late init var for the linked list. So let's create a private late init var. That's going to be our test list, and this is going to be a linked list implementation for integers. That's going to be right around there. So in our setup method, this is called before each test. I'm basically going to have to instantiate this test list class. So let's instantiate it to linked list implementation. Beautiful. Now we are ready. Of course, Kotlin gives us the constructor for free. There's nothing that we need to do right now. We don't have a failing test yet, which means we're still focusing on the right. No implementation yet on the linked list implementation class. So let's create our first test. To write the test in JUnit, we have to put the annotation test, and then we create a function that's actually representing the test. Let's begin with the simplest operation you can do on a linked list, which in my opinion is to basically append elements. This means appending them to the end of the list. So I'm going to create a test that's going to be called append element adds with empty list. It's going to add the element as the head of the list. Let's go as a simple scenario. It means we have an empty list, and now we're going to be adding an element, and this is going to be represented as a head. So how do we begin here? Well, we don't have implementation, but we want to test the way that we want things to be, which means we're going to act as if we had the implementation, and we're going to follow the compiler errors and the test errors in order to wrap the implementation around those errors. So for example, what we need to do, we need to append an element. All right, so we have our test list here, and we're gonna have to append, let's say, an element with a value of 0, since we're gonna be using integers for this example. And of course this doesn't compile yet, but we also need to assert something. So we're gonna use the JUnit static assert class, which is gonna make our lives easier. We're gonna assert that it's gonna be 0 when we actually go into the test list and we're actually getting the head. And we're gonna be taking the head value. And because the head is probably going to be nullable, because we don't always have a head, let's already prepare ourselves with a safe operator. So look at that. I'm going to also redundant operator name here so that it's imported as a static class, so we can actually access all the assert static classes methods. So look at that. This is obviously a failing test. It's not even a failing test. Now we have a compiler error, which means that we're going to have to start by actually implementing stuff on the left here. So how do we begin? First of all, we have an append method. So let's create an append method. And Android Studio can do it very easy for me because we can actually use option enter to give us like the implementation for what we're actually missing. So I'm going to rename that variable to value. It's still going to be taking a generic and it's not yet implemented. We can leave it empty for now. So no compiler error here, but we also see that what we have here is a variable inside the linked list. So this is easy. We're going to have to add the implementation for list. We can add on the constructor to have a variable named head. So it's going to be a head. That's type. Now what type is the head? Now it should be a type of node, a node that represents an element in the list. So we can actually do it as a my node, which is also going to be a generic. And what we basically have here, oops, now this should be in the signature before the variables. So we have a my node. Also compiler error. This is going to be like the beginning of the list, which means we have to create a class. So let's create that as, let's put it outside the other class, my node, which is basically here, and my node should have a value. All right, so what we're basically going to do is we're going to create a variable which is going to be the value, which is going to be of type T, of course, because this is a generic, and maybe put it as a now head should be nullable, by the way. Now this shouldn't be nullable. Let's not have the brackets yet. So look at that. What we have now is no compiler errors. Oh, except for our linked list here has an empty constructor that's no value passed for parameter head. So what we basically need to do is we basically need to add a default value for head, because creating a linked list, it should be empty by default. So now everything's fine. Now to run all the tests, I'm going to use Control Shift and R, which basically runs my test. I'm going to be using that run console here to see. We're not expecting the value actually to be 0 here, so we're expecting a failing test, of course. It's expecting 0, but actually what we have is null. Now this is obvious because right now we're expecting the head to be of the value 0, but look at that. This append method actually does nothing. Now in the test-driven development, you have to actually follow a more simplistic approach. Maybe we can say like a dump method, dump approach to actually approach this issue. For example, you have to go for the easier way to make the test pass. Don't try to go for the kill immediately. Start by wrapping your head around the problem, going slowly. And if the method works, the methodology works, then hopefully by the end you're going to have an algorithm that just works. That means that in this append method here, what we're actually doing, we have an empty list and we're appending one element, and we want obviously the head to be have the value of that element. Now, the easiest way to do that is you can actually come here and actually make the head be a node that actually holds that value. And if you look at that, now this should make the test pass. Let's see. Yep, we have a successful test. Now, you may be thinking to yourself already that, come on, obviously this is not the proper way to append anything on the list, because if you're trying to append a second element, it's not going to work. And I know that, but it's part of the process. You have to not rush. Let's go slowly. Let's do it the dump way. And as experience grows, maybe you can start fast forwarding some steps. I would not recommend that you do it in the beginning, because it's still very important to follow the steps of test-driven development. But with experience, you can start adding some shortcuts when you feel comfortable enough, when you have the ability to actually see in the future and being able to understand what's coming next, so that you can basically skip some steps that are maybe will be seeming a little bit redundant by then. So now we have to keep adding tests so that we can actually implement the functionality that we want. Right now we have an append element with an empty list, but this is not always going to be the case. Sometimes the list is not going to be empty, which means that we're going to have to create a second test. I usually copy paste when it's like the same idea behind the test, because I'm like really bored of rewriting the name of the test. So it's still going to be append element with non-empty list. So now we have elements inside the list, and it adds the element as the last, not head, element at end, let's say. So, which means that we have an append. In order to have a head, we're going to be appending 0. And then we're also going to appending 1, because now we have a second element. And what we need to do is we're going to have to see that 1 is the second element. So what head is pointing to, which means we're going to be doing head, next, and then we're going to take the value of next. Well, next is going to be the next node from head. Now, this shows that we need to actually change the node, my node class. So going over to the left, we're going to be adding var next, which is going to be, again, type my node of t, and it's also going to be by default null, because you could create a node without anything after that. So let's run the tests again. Let's see what happens. Of course, we have a test failing here. We're expecting to see 1, but we got null because head doesn't point to anything. And this is natural because we have appended the first one. Well, this worked over here, but when we append the second one, what we basically did is we replaced the head, as we can see in the implementation on the left, which means that something has to happen. So now it's time to actually think a little bit about the implementation. We have two cases, the empty list and the non-empty list. So since we have two cases here, we maybe have to add an if statement inside the append function. So let's try to do that slowly. Now, if the head is actually null, which means that we have an empty list, what we need to do is set the head to node. Alright, so this maybe covers the first case, this test over here. I'm pretty confident that it does, but we of course have to see that in action. And then let's say that we do not have a head, and then we are appending something else. What we need to do is we need to traverse the list until the last element, and then once we traverse the list to the last element, we are going to need to append that element as the next value of the current final element. I think it makes sense. So we have to find a way to traverse the existing list. To do that, what we need to do is we need to actually have a var for a current node, what we're basically looking at, which begins as head. And then we're gonna take advantage of a while loop. So while the current node has a next, so this is not null. So while we have places to be, we can actually make the current node look to the current node's next. So it's pointing to the current node next, and thanks to Kotlin smart casting, we basically don't need to actually check for that because we know that it exists. So when this while loop finishes and we reach a point where the next value is null, it means that this next value is ready to accommodate our new node that we have to create. We have to append. So after this while loop finishes, we're going to be pretty certain that if we do the current node dot next, we can actually create it as a new node. So this is going to be a my node that's actually containing the value. Let's think about it a little bit. Have we actually done things the way we should? If the head is null, we create a new node. This should be the simplest case ever, and we can actually guess that this would work. Let's see that if the head is not null, which means that we actually have elements inside the list, what we can see that we have a current node, we make it point to head, and then we start. Is the next, if only head exists in the current list, then this while loop will never start because the next is already null, and we can say that this loop will not be actually running. We're going to go immediately to the next after the head, adding the my node. Otherwise, if we have a next node, we're going to keep doing that again and again and again until we reach a next empty node, which we're going to be filling with a new node. Best way to actually test the hypothesis is to actually run the tests, which are actually in place to show us that we have the acceptance criteria for appending. And look at that. Now we have a green check here, which shows us that our tests have passed. And the nice thing about test-driven development is that if you're going to go here and you can actually run the linked list test implementation with coverage. All right, we can see if we're moving inside the Kotlin algos, look at that. 100% coverage in everything. Oops, for some reason I got back. Let's try that again. This is 100% coverage in everything, and we actually have an 85% line coverage in the linked list implementation, which is kind of interesting. But how is this possible? Well, it is possible because in our current test, if you look at that, we're actually testing that we only have two elements and we never actually have to traverse the list until the end because immediately that next value points to null. So this code here has never been tested, which is a very good indicator for us. So what we basically can do is we can have to name this test, add a new append for 2. And now we're going to be checking that the head of the next, let me go ahead and close that here. Now we're actually looking for the second element here, but we're actually going to go one step further. We need 2 to be, we can actually put 2 assertions actually. So the next value of head should be 1, and then create a second assertion. Of course, you can have as many as you want. It's better to actually split those assertions in different tests if they are different, but if they are of the same actually type, then it makes sense to have them both in the same test. So we're asserting that the first one, we're expecting that the second element is 1 because we added it as a second, and the third element should be 2. So in the next value here, let's go one step further and add one more next value here. So like this, the next of the next node should be 2. And let's rerun the tests. Yep, the traversion works. And what's more interesting, we saw that we didn't have 100% line of coverage, but if we run the coverage again, we can go ahead here and go into our class that we created, and look at that. Now we have 100% of lines covered. This is helpful. Line coverage is not the best indicator for a good test coverage because sometimes this can lie. You can actually pass through one line of code but not cover all the cases. But it's a good indicator nevertheless. For example, here we thought that we had covered everything, but this showed us that there are some lines uncovered, which means that this code could potentially be not working the way we wanted. We had never tested that this while loop worked because we never actually needed to get inside it. But now we do, and we know for a fact that our append code works. And it looks pretty nice. If you notice the pattern here, what we actually did, we actually mandated through the test how this code should be written. We didn't actually think of the algorithm so much. We went with a very slow way. We started ad hoc adding code just to make a simple test pass. Then we had a little bit more of a complex test. This code was not enough. We had to refactor. We had to add some logic. But at the same time, this logic was so slowly being added that it made so much sense, and you can actually control the way this is created. And by the end, not only do you have a working function, but you get the test for free. And this for free, of course, is not actually for free because we did it, but it was a fun process. And through this process, by the end of that, you can actually say that you have also tested your code, which is always a very good class. And in my opinion, you should always strive to have as much of a code coverage as possible. Now this is fun, so let's start doing something else. Now we added the append, but sometimes you don't want the element to be in the end. Maybe you want to prepend an element and actually put it in the beginning. So let's begin with our test. I'm going to copy the first test because I think it will look a little bit like that. So renaming prepend element with an empty list, it adds the element as head. Of course, because when you have an empty list and you prepend anything, the head should always be the first value that should be actually set. So I'm going to do a prepend here, 0, and we're actually asserting that the head is equal to 0. Nice. So we don't have a prepend method here, so as we did before, we actually going to create it with Android Studio. Rename this to value. It's going to be a generic type. Thank you very much. And like we did before, we just want to make the test pass. So the head should be a my node value. And let's see the test running. Very nice. It's a good idea actually to run all the tests because sometimes you're changing stuff and the other tests are failing. So make that a habit to always run the whole test file. So unless it's very slow, I would encourage you to always run all the tests at every step of the process. So, okay, this is easy. Let's start doing something more difficult though. Let's start prepending elements to a non-empty list. Again, I'm going to copy paste that test because I'm lazy, and prepend the element with non-empty list, adds the element as head, of course, and makes it point to previous head. Now, this is not the best name I've ever written in a test, but you get the idea. We want to add the first the element that we're adding as the head, but now the previous head should be the next. So this head should point to the previous head. I'm pretty sure I could have come up with a better name, but oh well. So we have a prepend 0. This is not an empty list, and I'm going to be prepending another element before that. So let's make a -1. This is going to be the first element now, and hopefully the second element should be 0. So the head should be -1 because this is the first element now, and we also want to assert that the next of head is actually 0 now. Let's run all the tests again. And of course it fails. Of course it fails because we prepended -1. This makes it as a head. Yes, we can see from the production code that it actually does, but it does nothing to keep the 0 alive. 0 is no longer inside that list. So how do we do that? Again, we should make a node that has a next node. We have a node that can also add a next node while it's being created. So what I'm thinking is, why don't we create it like that? Let's split it into two cases again. I'm going to keep that on the top, basically right above it. So if we have an empty list, so if head equals to null, then we can actually create a new node. So this is the case of the empty list. Simple as that, and it also looks exactly the same as append. Very nice. So now we have to actually think a little bit, because naturally we need to put the previous head, if the head exists, we need to put the previous head as the next value of the new node. So let's create a temporary current head. Current head, it points to the head. Let's keep that for now so as not to lose it. And we can actually make the new head, the head, make a new head with my node with a new value that we're trying to add. But now we can also, on the constructor, add the next value to be the current head. Let's think about that. We're actually keeping the head in a variable. We're reassigning this head to my node, but since we have that variable, we can actually put it as a next. So now here, the next value that we're going to be pointing at should be the previous head. Okay, let's try to run the tests again. Nice, we have a green arrow, which means we have a green check, which means that now this code works. And the typical test-driven cycle says that you can go from red to green, which we now have green, and then it says refactor. So it's time to clean up a little bit what we have actually done. And Android Studio basically gives me a hint here that this assignment can be lifted out of if. It doesn't make a huge difference, but let's do it to be more Kotlin friendly. And I'm also going to make the spaces a little bit better, remove some unneeded lines. So we are assigning head always because we're prepending an element, which means this is going to be the start of the list. But if the list is empty, we're setting the new node, but we're making sure that if the list is not empty, we don't lose the previous head and we actually assign it as the next of the new head. Pretty good for now. So I'd say that this is like the intro for test-driven development inside a list. We basically covered the most basic operations you can imagine in a list. We're appending and prepending. We have more things to do, and we're going to be actually taking place, this is going to be taking place in the next part so as to keep it concise and easier to digest. Thank you for watching and see you soon with the rest of the test-driven linked list implementation in Kotlin.